I hold it in my hand. I spin it towards you. And I'm going to put my right hand towards you and my left hand away from you. The spin angular momentum is now in this direction. So I'm going to give it a torque like so, that means up. And what will the wheel do? The wheel will do this. It's very non-intuitive. Watch it. Isn't that strange? You wouldn't expect that. I will do it again. So I'm going to torque by pushing my hand towards you. And the wheel does something completely unexpected. It simply tilts. If I torque the other way around, then the torque, of course, will make it flip like this. I'll give it a little bit more spin angular momentum. So now I move my left hand towards me and towards you, and my right hand towards me, and then I expect that the wheel will do this. And that's what it does. Extremely non-intuitive. These torques applied to a spinning wheel always do something that you don't expect. However, there is one thing that always helps me in terms of guiding me, and that is you can always predict that the spin angular momentum will always move in the direction of the torque, which is this external torque that I applied. Let's go over nicely as I described it to you. You are, as an observer, in this direction. This is the direction of 26/100. So you are viewing the wheels like this. They're spinning towards you. That's what I will do shortly, and that's what I implied now. This is my right hand, and this is my left hand. The separation between my right and left hand is little b. So the torque that I apply is Bf. It's this arm, so to speak, times this force. And the force is perpendicular to the arm. I apply a torque for a certain amount of time, delta t. When I do that, I add angular momentum in this direction. But the wheel was spinning in this direction, you see it. And so the angular momentum of spin of the wheel is in this direction. I add angular momentum in this direction. And you see that here. So this was originally the spin angular momentum of the wheel. I torque for a time delta t. And so I add angular momentum like this. And then I stop. So I only torque for a short amount of time and I stop. That means after I have stopped, the angular momentum of the system as a whole can no longer change because there's no torque on the system. And the only way that nature now can solve that problem is to tilt this wheel in the way I've indicated here and to make it spin in this direction, and it will stand still. In other words, I hold it in my hand, the wheel. I will get it. I give it a spin. That again. We have here the spin angular momentum that you saw was pointing in this direction, and I apply the torque in this direction. It's a vector. And what does the spin angular momentum do? It goes in the direction of the torque. And then when I stop with my torque, then of course nothing changes anymore. And so what happens is this wheel tilts. But notice that L, the spin angular momentum, has moved from here to here. And I was torquing in this direction, so it moves towards the torque. If you have digested this, then you can test yourself now. Now we have the same wheel. I'm going to rotate it in exactly the same direction. But now I'm not going to torque like this in the z direction, or like this in the minus z direction. Now I'm going to do this, or I'm going to do this. Try now to really concentrate on what I just taught you. And try to give an answer to the following question. The wheel is rotating. I hold it in my hand, and I'm going to torque it like this, so that the torque vector is in your direction. Angular momentum was like this. Torque is like this. What will the angular momentum vector do? Move in the direction of the torque. What will the spin angular momentum vector then do? If the torque is in this direction, it will do this. It's going to move in the horizontal plane. Very non-intuitive, but that's what it will do. And I will show that to you. I'm going to spin this wheel I'm going to spin it with a high angular momentum, high spin angular momentum. And then I'm going to sit on this stool, and I'm going to torque exactly as you see on the picture on the right. I'm going to torque like this. And as long as I torque it like this, that spin angular momentum wants to go around in the horizontal plane. And when I torque the other way around, it will go back in the horizontal plane. I'm going to torque exactly as you see on the picture there. You ready? I stop the torque, nothing happens. I torque backwards, I keep torquing. I keep torquing, I feel it in my hand, I really have to push. I keep torquing, and I stop torquing, and it stops. So the angular momentum vector is chasing, so to speak, the torque. Isn't that non-intuitive? Very non-intuitive. It's also dangerous sometimes. I have here a string, a rope, like we have there. And I stick into that rope, I attach to the rope this wheel, just like so. And I let it go. Well, we all know it will happen. Clunk. It's clear. All right. But now I'm going to spin it before I let it go. So we'll spin it up, and then we'll put it in here. Notice the way I'm spinning it. I'm holding it away from you now. I'm going to change it and do it differently next. There it goes. About 10 seconds. Isn't that amazing? And it rotates seen from below clockwise. Now it's going this way, and I'm going to redo the experiment, changing the direction of rotation, and then it will go the other way around. And now the angular momentum, is it rotating like this, is pointing here. Spin angular momentum is pointing like this. Torque is like this, and so the spin angular momentum is chasing that torque. I'm the spin angular momentum, I'm the torque. This is the torque. It's chasing it. All right, so I had this in my right hand. That's all right. And now I will, so when I spin it up, that's right. So let me now change the direction. I'm turning it over, and now I'm going to spin it up again. Angular momentum is now in this direction. See, it's turning the other way around. Angular momentum is in this direction. Torque is now towards me. Angular momentum is changing the torque. I've changed the direction of the spin angular momentum. I've not changed the direction of the torque, and now it is rotating as seen from below counterclockwise. Before it was rotating clockwise. If I can increase